Today we are going to do miscellaneous miscellaneous exercise with important questions. First question number 24, that is of the type Ex fx plus f dash x dx. If you will integrate this, you will get that it is coming Ex fx only. So directly using this result, you can use this, write this answer. No need to show the steps and all that. We will just say this is of the type Ex fx plus f dash x, then answer is Ef fx. If you do it by parts, you will get the same answer only. Check. If I am doing Ex fx by parts, f dash x, fx I am taking as first function, integration of Ex is second function. Now f dash x, Ex dx, right? So if I have integrated this function, just remember. If I have integrated only this function by parts, I am getting this, and this will get cancelled with this, right now? So using this result, you can directly say that this is of the type Ex fx plus f dash x. So answer is Ex fx. So how to do question number 24? By this method. This is pi by 2 to pi Ex 1 minus sin x upon 1 minus cos x dx. Right? So that is equal to pi by 2 to pi Ex as it is, numerator as it is, 1 minus cos x is 2 sin square x by 2, right? dx. So can I write this as pi by 2 to pi Ex 1 by 2 cos x square x by 2 minus 1 by 2 sin x by 2 cos x by 2 will be, because sin 2 theta, if I use that formula 2 sin x cos x, so half angle will be this. 2 sin square x by 2. So 2 cancel, 1 sin cancel, so I'm getting cot x by 2. So this is pi by 2 to pi Ex 1 by 2 cos x square x by 2 minus cot x by 2, right? Now, what is the differentiation of cot x by 2? That will be minus cos x square x by 2 into 1 by 2. No? So if I take minus over here, so isn't it becoming plus? So if you take f of x as minus cot x by 2, what will be f dash x? Cos x square x by 2 into 1 by 2. No? So isn't it of the type? This is of the type Ex fx plus f dash x. So answer is Ex fx plus c only, because this is a definite, so no need to put right c. I have written indefinite, so I'm writing c. So the answer will be Ex with minus sign cot x by 2, limit pi by 2 to 5. So if I put upper limit minus common, e pi cot pi by 2 minus e pi by 2 cot pi by 4. So this will get 0 as cot pi by 2 is 0. That is infinity, so cot will be 0. No? So answer is coming e pi by 2 into what? As cot pi by 4 is 1. Clear? Next question. Sin x, cos x, 0 to pi by 4 sin x, cos x, in the denominator cos 4x plus sin 4x dx. So let us divide this by cos 4x. 0 to pi by 4 sin x, one cos is gone, So this is cos cube x in the denominator. This is 1 plus tan 4x dx. So that is equal to 0 to pi by 4 tan x sec square x na in the denominator 1 plus tan square x square, right? Why I have taken tan square? I am going to take tan square x as t. So 2 tan x sec square x dx is equal to dt no, by substitution method. So, and now if you want to change the limits, you can change over here. Otherwise, you can directly take in the end, but you have to take just indefinite integral only then. So, tan x sec square x upon 1 plus tan square x whole square dx is equal to dt 1 by 2 upon 1 plus t square, which is equal to half tan inverse t. So if I put t, half tan inverse tan square x, right? So substituting in that, it will be 0 square half tan inverse tan square x limit 0 to pi by 4. So if I put the limit, that will be half outside tan inverse tan pi by 4 square minus tan inverse tan 0 square, right? Why I am writing square over here? So that you remember to, if the value is coming, any other angle is given, you remember to square it. So this is tan pi by 4 is 1, 1 square is 1, so tan inverse is again pi by 4, right? And this is 0. So answer is pi by 8. But if you want to find the limits over here, what will be the limit for this? If you want to change the limit, x is equal to 0, t is equal to 0, x is equal to pi by 4. If you put pi by 4, so t is equal to 1, na? Because tan pi by 4 is 1, 1 square is also 1. So then you will integrate it using 0 to 1 dt half 1 plus tan, 1 plus t square, right? Any way you can do. But if you are not using the limit, you are not sure of changing the limit, then just pick indefinite, find out the value, substitute t, and then take the upper limit from here. You can this as I1 and so on. You can substituting in that. Clear? Next question. 26. Question number 26 is 0 to pi by 2 cos square x upon cos square x plus 4 sine square dx. So let us divide it by cos square. So that will be 0 to pi by 2 dx upon 1 plus 4 tan square x dx. Dx is taken upon. So now if I take tan x as t, sec square x dx is equal to dt. What will be sec square x? dt upon 1 plus tan square t, na? So 1 plus t square. Why? Because 1 plus tan square x is equal to sec square. So I can write 1 plus t square in place of sec square, right? So that is what I have done. So you are getting over here, just use it as I1 dt upon 1 plus t square into 1 plus 4t square. Now you can do this question by partial fraction. For partial fraction, let t square is equal to x. So I am getting 1 upon 1 plus, not x, take it as u. 1 plus u, 1 plus 4u. That is equal to a upon 1 plus u b upon 1 plus 4u. So 1 is equal to a into 1 plus 4u plus b into 1 plus a. So for u is equal to minus 1. This is 1. A into 1 minus 4, and this will become 0. B will become 0. So a value is coming minus 1 by 3. Right? And if I want to make a is equal to 0, then I have to take u is equal to minus 1 by 4. Na? So u is equal to minus 1 by 4. So this is 1, a is 0, b 1 minus 1 by 4. So that is 3 by 4, b is equal to 1. So b is equal to 4 by 4. Right? So what partial fraction I am getting? A is equal to minus 1 by 3. So this is dt upon 1 plus t square into 1 plus 4t square, that is equal to a is minus 1 by 3. So minus 1 by 3 dt upon 1 plus t square plus 4 by 3 dt upon 1 plus 4t square. So this is minus 1 by 3 tan inverse t 4 by 3. Now remember, if you are taking this as 1 plus 2t square, this 4t square as 1 plus 2t square, then this is tan inverse 2t. Then remember to differentiate t in the denominator. So this is tan inverse 2t upon total differentiation of 2. 2t is 2, right? Otherwise, remember to take again 2t as another function, or take 2 common from here. So it will be 1 by 4 and t, and this will be 4 here, right? So that way you can do. And put the limits and find out the answer. Next question number 27. 5 by 6 to 5 by 3 sin x plus cos x upon sin 2x, right? So that is equal to, remember, in these type of questions, when there is plus in the numerator, you will try to take sin x minus cos x in the denominator by using this method. Sin square x plus cos square x minus 2 sin x cos x. What is 2 sin x cos x? Sin 2x, no? And this is 1. So it will get sin 2x. So can I get sin 2x from here? What will be that? Sin 2x is equal to 1 minus sin x minus cos x whole square. And what do we have over here? Square root. We will get the whole square. So let us try to solve this question now. So this is 5 by 6 to 5 by 3 sin x plus cos x upon 1 minus sin x minus cos x whole square. Remember, whenever you get sin 2x in the denominator in this type of questions, first you will check what is there in the numerator. If it is plus, you will take minus over here. If it is minus over here, you will take plus over here, right? If here in the given it is plus, you will take minus supposition over here. If here it is plus, you will take minus over here. And if it is minus over here, you will take plus over here. You will take plus over here, right? Clear? So now if you suppose sin x minus cos x is equal to t. So it will be cos x. Cos x is minus minus. So it will be plus sin x dx is equal to dt. right? Now, if you want to change the limits, good. Otherwise, just pick it up like indefinite integral, solve it till last, and then put the limits. So if I put the limit, sine pi by 6, sine pi by 6 is 1 by 2. So that will be difficult for you to handle at it will, as it will get in the 1 minus root 3 by 2, right? So let us take it as indefinite integral only. So sin x plus cos x upon 1 minus sin x minus cos x whole square is equal to dt upon 1 minus t square, right? Which is equal to sine inverse t, which is equal to sine inverse sine x minus cos x, right? Now substitute this value over here. So this is equal to sine inverse sine x minus cos x, upper limit, lower limit, pi by 6 to pi by 2. So let us substitute upper limit sine inverse sine pi by 3 minus cos pi by 3, then minus sine inverse sine pi by 6 minus cos pi by 6, right? So that is equal to sine inverse, this is getting root 3 by 2 minus 1 by 2, right? Minus sine inverse 1 by 2 minus root 3 by 2, right? So this is sine inverse root 3 minus 1 by 2 minus sine inverse uh, root 3, 1 minus root 3 by 2. So if you take minus sine inverse minus x, that is equal to minus sine inverse x. No? So using that property, you can just solve this question. Next question is, in this question, rationalize it and then do. Question number 28. 0 to 1. I am rationalizing it plus x, and in the denominator it will be 1 plus x whole square minus root x whole square dx. So that is equal to 0 to 1 root x 1 plus x in the denominator it is 1 plus x minus x dx. So just integrate this 1 plus x and root x. You know this is how to do it. 1 plus x raised to power 3 by 2 upon 3 by 2, and then put the limits. X 3 by 2 upon 3 by 2, put the upper limit and lower limit as 0. Next question 29. 0 to pi by 4 sin x plus cos x upon 9 plus 16 sin 2x. Again, sin 2x is there. This sin 2x is there, and in the numerator it is plus now. So what will you take? Sin 2x as 1 minus sin x minus cos x whole square, like previous one. Because sin x minus cos x whole square is sin square x plus cos square x, which will give you this one. And minus sin 2x, which is this. 2 sin x cos x is sin 2x, which is this. So substitute that. 0 to pi by 4 sin x plus cos x upon 9 plus 16, 1 minus sin x minus cos x whole square dx. So this is 0 to pi by 4 sin x plus cos x, 9 plus 16. This 9 plus this, if I multiply 25 minus 16 sin x minus cos x whole square dx. So sin x minus cos x t, so sin x Again, sin x minus cos x as t. So, cos x plus sin x dx is equal to dt, na? Substitution. So, and put the limit. If I take sin x as 0, cos x will be minus 1, sin 0 minus cos 0. That is equal to, when t is equal to t value. So that will be minus 1, na? And when pi by 4, it will be minus 1 to 0. Why? Because sin pi by 4 is minus cos pi by 4. That is 1 by root 2 minus 1 by root 2, na? 0. So t is 0 for that. So this is minus 1 to 0 dt upon 25 minus t square, 16 t square, sorry, 16 t square. Or you can just use, so you solve this by indefinite and in the last, you can put the limit. I have shown you both the way you can do it. Now take 16 common, otherwise you have to remember that you have to integrate that. So a square minus x square, that is log formula, na? So use that formula and find out the answer. Clear? A square dx upon a square minus x square. So use that formula. So this is minus 1 to 0. I am taking 16 common. dt upon 25 minus 16 minus 3. Use this formula to solve this. Clear? So use this formula to integrate this and find out the answer. Clear? Next question, 30th. Tan inverse sin x. So what will you do in this question? Sin 2x will be 2 sin x. This will be 0 to pi by 2. 2 sin x cos x, no? Tan inverse sin x dx. So take sin x as t, cos x dx will be dt. Sin x is equal to 0, so t is equal to 0. When x is equal to pi by 2, then t is equal to 1. Sin pi by 2 is 1. So limit will be 0 to 1. 2 t tan inverse t dt. Clear? Solve it. 2 will come out. So by parts 0 to 1 t tan inverse t. Islet. Use islet. This will be your first function. This will be your second function. Then solve it. So this is tan inverse t into t square by 2, 0 to 1 minus 0 to 1. Tan inverse is 1 plus t square into t square by 2 dt. So that is tan inverse t into t square by 2, 0 to 1 minus t is 1 by 2 outside t square. So I can do 1 plus t square minus na 1 plus t square dt. Otherwise, I have to divide because numerator and integration if numerator and numerator power is equal to or greater than denominator. Then you have to divide algebraic division, long division. Okay. So better to do this way. So one add and subtract. So this will be 0 to 1. So t square by 2 tan inverse t. We put the limits at the end. Minus 1 by 2. So this is 0 to 1. 1 plus t square upon 1 plus t square is 1 dt minus 0 to 1 dt upon 1 minus 1 plus t square, which is equal to tan inverse t. So solve this. So this is t square by 2 tan inverse t 0 to 1 minus 1 by 2. 0 to 1 is t, na? So this is t minus minus plus tan inverse t limit 0 to 1. Clear? So substitute the values here also 0 to 1. So this is when you put 0, this is 0. When you put 0, this value will be 0. So when you put 1, so this is 1 by 2 tan inverse 1 is pi by 4. Right? minus 1 by 2 into 1 because of lower limit will be 0. Same here, plus 5 by 2. So, solve the question. Last one is mode 1. So, this is, I told you how to do this. X minus 1. 1 is the 0 now. Means if I put 1 over here, if I put 2 over here, if I put 3 over here, you will get the function 0. And 1, there is nothing to the left, only positive. So 0 to 1, x minus 1 dx. Then it is 2. So the second one, 2. 1 is in the left now, and 4 is on the right. So minus here, plus here. So this is 1 to 2 with minus sign, x minus 2, and 2 to 4, x minus 2, positive. Then 3, for this, 3. 1 is this side left, 4 is this side. Here it is negative, here it is positive. So minus 1 to 3, x minus 3 dx plus 3 to 4, x minus 3 dx. So now one question, there is example in your book, but important question is there, this one, which is a long method in the book, but sin to x method we can use over here also. How? Check. This is for example 39, cot x plus tan x dx. So that will be equal to cos x by sin x now. And this will be sin x plus cos x. Wait. So dx. So this is, if I take the LCM, it will get root cos x into root cos x, and here it will be sin x. In the denominator, it will be sin x cos x. So what can I do? Can I multiply and divide it by 2? So what will that be? Cos x plus sin x upon sin 2x by root 2. By root 2, so that will come over here. Right now? So what will you do now? Root 2 cos x plus sin x, and this is written as 1 minus sin x minus cos x whole square. Use t and dt. So root 2 dt upon 1 minus t square, which is sin inverse t. So your question has become so simple. Root t sin inverse t, which is equal to root 2 sin inverse sin x minus plus x. This is the answer, plus 0. Clear? Instead of doing this long method, we have done this method, and the answer in the integration we can use any method to answer multiple different. Clear?